Hi, in this video, we're going to combine ratios where each parts of the ratios are going to be subdivided in some way. So let's look at the problem. We've got green shapes and purple shapes. Some of the shapes are triangles and the rest are hexagons. And then the ratio of green shapes to purple shapes is 3:5. And then of the green shapes, the ratio of green triangles to green hexagons is 1:2. And of the purple shapes, the ratio of purple triangles to purple hexagons is 2:3. So there's a kind of like subdivision going on here, because you first got the ratio of green shapes and purple shapes, and then of the green shapes, you're splitting that in a ratio, and the purple shapes, you're splitting that in a ratio. And when you have this like subdivision like that, a really good way to write it is as a tree. And I'm going to use a tree of fractions. So we firstly got, in our tree, we're splitting into green shapes and purple shapes. And let's think about fractions involved. Well, the ratio of green to purple is 3:5. Now, the total parts of shapes is 8 parts, because 3 plus 5 is 8. And of those 8 parts, 3 of those parts are green. So 3/8 of the shapes are green. And of the 8 parts, 5 parts is purple. So 5/8 of the shape are purple. So that's how we turn a ratio into fractions. Now, of the green shapes, it's then split into triangles and hexagons. So triangles, I'll draw a triangle, and hexagons, draw a hexagon. That ratio there is 1:2. So we look at the total number of parts again. 1:2, that's 3 parts in total. And of those 3 parts, one of those parts is green triangles. So it's 1 out of 3, which is a third. So that's saying a third of the green shapes are triangles, and therefore the remaining 2/3 of the shapes are going to be hexagons. It's 2 parts out of 3. We can do the same for the purple. We're going to split the purple shapes into triangles and hexagons. And we're given this ratio here. Purple triangles to purple hexagons are 2:3. So that's 2/5. And 3 parts out of the 5 are hexagons. So it's 3/5 of the purple shapes. Now, we can use this tree to find what fraction of all the shapes are triangles. So let's follow a tree down. Where do we have triangles? Well, we've got green triangles, and we've also got purple triangles. I should probably use the purple for the purple root, but never mind. Now, the way we do this is, if 3/8 of the shapes are green, and of those 3/8 of the shapes that are green, a third are triangles, then a third of the green shapes, so a third of the 3/8 of the shapes are going to be triangles. So we want to do a third of 3/8, and the way we do of is we do it as times. When you have a fraction amount, you just times them. So we want a third of the 3/8. We just times those fractions together as we go down the tree. And then similarly, if you want the fraction of the shapes which are purple triangles, well, 2/5 of the 5/8 of the shapes which are purple triangles. So again, it's 2/5 of 5/8. You do 2/5 times 5/8. So we do 2/5 times 5/8. Let's put those each in brackets. Now, this represents the fraction of shapes which are green triangles, and this represents the fraction of shapes which are purple triangles. And in total, that will give you the total fraction of shapes which are just triangles, either purple or green. So we just add those together, and then we're going to do that. We're going to simplify. So we multiply the numerators, that's 3, multiply the denominators over 24, plus 2 times 5 is 10, 5 times 8 is 40. Let's just simplify that. 3 over 24 is an eighth, plus 10 over 40 is obviously a quarter. And then if I just write the quarter as 2/8, that's going to give you 3/8. So therefore, in total, that's 3/8, not 3/5. 3/8 of the shapes are triangles.